Okay, here we go for part 2. This is the page filled out. So again, you can pause the video and make sure check your answers. Here's the second one, and again, you can pause the video. I'm going to explain real quick about some of this. The whole trick of this, not really a trick, but how this works is that because I know the position of the shape of this little acute triangle, I also then know the coordinates of A and B. So for instance, in this one, like this is the shape of this triangle where the x coordinate is A and the y coordinate is B. When this one here, then if the little one is B and the big one's A, well then that means the x coordinate is B and the y coordinate is A, and so on. Similarly over here, for this little triangle, this little thing is B, except for it's to the left, so that's why the x coordinate is negative, and then the y coordinate is the same as this one. And when I get to the negative theta, the x coordinate stays the same, but the y coordinate is negative. All right, and so this ends up being a whole bunch of relationships that we can see. So for instance, right here, sine of negative theta equals negative sine theta. That came from this one right here, right? Because we said B was sine theta, so then sine of negative theta equals negative B, which was sine theta. So this is an identity. And in fact, if I just put the negative on the other side, what does this just show? This just proves, I've just proven, therefore, y equals sine theta is odd. This statement is the even statement. And then I get a whole bunch of, by the way, these are the same as these, but except for these are in radians, which is the one, these are the ones that we'll use mostly. These are called the cofunction identities. And like it says here, now, although interesting and informative their own way, these formulae will allow us to develop more formulae, each more interesting and useful than the previous formulae. Just you wait. It's going to be awesome. But today it's kind of a weird day of homework. Basically, the whole goal is developing these formulas, which we've done, and the homework is basically a little bit silly, except for it helps us practice these rules. We need to remember these rules. And here are the rules. And you've got them sitting right there in front of you on your note. There are some other rules that I've intentionally omitted. And I've intentionally omitted to give you a chance to think about them. And the first one and you can only get one bonus. Okay, so the first one to give me the rule about tan x. So is tan x even, odd, or neither, with an explanation. You must explain. And there's only one bonus per person and one bonus per rule, right? So, okay, the first person's going to give me whether tan x is even, odd, or neither, and an explanation why. Then they can't get another bonus mark, and someone else can't get a bonus mark for tan x. So how are you going to do this? You're going to post it on the Facebook group, okay? I don't want any paper on this one. You post it on the Facebook group, earn yourself a bonus. Now, there's a lot of stuff to remember, but how do we remember? There's lots of ways. One is you could remember this development, which is a little bit complicated, but still not so bad. But I want to talk about a couple of other ways that I can remember this development. One is, especially for these ones, because these ones are actually just a triangle. Now, let me show you what I mean here. If that's theta, then I have this side, and this is the hypotenuse, right? If I want to talk about this angle, right? This angle is going to be pi over 2 minus theta, isn't it? Right, because the three angles have to add up to 180 or pi. So then if I want to talk about the sine of that angle, that's going to be y over r, right? Opposite over hypotenuse. Opposite over hypotenuse. But look at what y over r is. From this perspective, y over r is the adjacent over the hypotenuse, which is the cos of theta. Can you see that? From this angle, this is the adjacent, that's the hypotenuse, and this is the rule. And so the first two rules go in this triangle. Anyway, another way to remember the other ones, and this one's a little more complicated, but it's not so bad. This is kind of like our development, but if this is the point x, y, and this is theta, right? If I draw a line that's perpendicular to this one, right? First of all, this slope, by the way, is rise over run, y over x, right? The slope of this line is y over x. And then if I add 90 degrees to it, pi over 2, then it's a perpendicular line. What's the slope of this line? Still goes through the origin. The slope of this line is perpendicular. It's the negative reciprocal. Negative reciprocal. So if I wanted to get what this point is, negative reciprocal, this is going to be x, because it's positive, and negative y. So if I wanted the sine of pi over 2 plus theta, this is going to be the opposite side, which is just x over 1, I guess, if this is the unit circle. But that, what's that? That's just the cos of theta. You see that? Now if I want to do the cosine of pi over 2, and this is the only one that's that's tricky, because this is the only one that's got a negative involved. The cos of pi over 2 is the x coordinate of this point, which is negative y. Well, what was y? Y was the sine of theta. But I got a negative sign there, so it's negative sine theta. And this is the only one that's got a negative that's a little bit different. Another way to remember some of these, and this is maybe people's favorite ways, is to think of the transformations. So for instance, this one here, sine pi over 2, pi, 3 pi over 2, and I won't draw this all, but there's sine theta. But if I wanted to think of y of sine theta plus pi over 2, what do I have to do? I have to move this one left pi over 2, right? So where it starts here, I go left pi over 2, left pi over 2, left pi over 2, left pi over 2. There's my new graph. This is the sine of y equals the sine of theta plus pi over 2. Oh, what is, oh, that's the cos graph. And I can remember it that way. I can remember it that way as well. So again, the goal tonight is to be able to recall these or develop them if we need to. The homework is a bunch of exercises to try and help us through this. So the idea is we're going to apply one of our cofunction identities. We're going to do one of these things to this and get a different form. So I guess the idea is it's going to be one of these ones, right? Sine of something and sine of something. So the question is this got pi over 2 added to it or subtracted? Well, what would pi over 2 be with 12 as the denominator? Well, pi over 2 is 6 pi over 12, and then I can see quite quickly, hopefully, that it's this one. And in fact, I could probably think about what theta is, right? If this has to be this, so I'm doing a little bit of work in the margin, pi over 2 minus theta equals 5 pi over 12. I think pretty quickly, now I get my homework in the way here. Let me get rid of this. This is common denominator. If I wanted to solve for theta, if you can't see this clearly, add theta to both sides, and I'm going to get what some people saw probably straight off. Theta is equal to pi over 12, right? So here, then I think of, well, what's this? I'm going to use this little formula, pi over 2 minus theta, and that was equal to cos theta, right? And I decided to use this one because it was sine and because this angle here was less than pi over theta. So I knew that there was pi over 2 minus theta. I knew that it was the subtract one instead of the add one. And I just, through my little calculation here, determined that theta was pi over 12. That's it. That's what they want you to do. Done. Let's try another one. Okay. And some people will be very good at this, and some people will have to use quite a lot of calculation here. Again, which formula are we going to use? Well, it's going to be a cosine one. It's going to be this one or this one. But the question is, am I adding or subtracting from pi over 2? So is this pi over 2 plus theta or pi over 2 minus theta? Well, what would be the cutoff spot for pi over 2? Well, this number would have to be half of this number, right? Just like it was 6 and 12 over here. This would have to be 4.5. So I know I'm using this one, right? I'm using this one. And then I can do a little calculation. I want pi over 2 plus theta to be equal to be 7 pi over 9. How do I calculate what theta is? Because then I know I'm just going to apply that one formula. I'll have to look it up in a second because I haven't got them memorized yet. Have you got them memorized yet? Hopefully, sometime soon. Common denominator is 18. 14 pi over 18 minus 9 pi over 18 is 5 pi over 18. So that's what theta is equal to, unless I made an arithmetic error. No, that looks pretty good. 5 pi over 18 is an acute angle. So then I've just determined what my theta is. So what's the rule I'm going to use? Oh yes, that's right. The one where we're adding theta to pi over 2 for cosine is the one where it's a negative sign of theta. So cos of pi over 2 plus theta, plus, because this thing's more than pi over 2, is equal to negative sine theta. That's the one we're going to apply. And we just determined that theta is 5 pi over 18, negative sine 5 pi over 18. That's it. Done. That's all they want you to do. When would we ever use this, or why is it important? Well, the simple answer is just not that important. But these formulas are, and this allows us to practice them. So that's a little bit of weirdness there, this idea of equivalent trig expressions. And of course, where is it going to get more important? When we start doing trig identities, right? This is where we're headed, is into proving identities, and that's coming soon. All right, that's it. Have fun with your cofunction identities. Don't get too frustrated trying to find your thetas. It will come. Be patient.